Hi students, welcome to HSC Earth and Environmental Science and Module 6 on hazards. This is video number 12. We're going to continue our little series on climatic phenomena and this time focus on East Coast lows. The learning intention for this particular video is for you to evaluate the causes and impacts of climate phenomena on a local ecosystem, including East Coast lows. We need to describe the cause of these East Coast lows, the impact, and also evaluate exactly what impact they can have on our local environment. This is quite a topical issue for us at the moment because there's a huge amount of rainfall on the east coast of Australia, particularly between around the Gold Coast and down through Lismore, and it's causing an enormous amount of flooding. And it really does highlight exactly this issue of not just what East Coast lows are or how they can form, but also the kind of devastation that they can wreak. So firstly, what are East Coast lows? Well, East Coast lows are intense low pressure systems which can form at any time of the year, but tend to be more common in the autumn and the winter. Now, of course, we're right at the end of summer. This is the last day of summer for 2022. And so you wouldn't necessarily think that this would be the ideal time for East Coast lows to form. But there's a couple of different ways in which they can form. They tend to be combinations of low pressure systems and the warm water of the East Australian current. And these two things feeding together tend to generate these low pressure systems, which basically air rising and the pressure at the surface is low. And what this does is it draws air in, and often, particularly as they form over the water, they bring huge amounts of rain onto the coast. So the associated storms that we get as a result of the formation and movement of these East Coast lows can produce quite extreme rainfall events. And that's really what we're in the middle of right at the moment. Particularly a lot of people in northern New South Wales and southern Queensland really experiencing some extreme rainfall, flooding, expected gale force winds may be accompanying that, and also often rough seas are another side effect of these East Coast lows. The worst of the storms are produced when we get intense low pressure systems moving across Australia being blocked by high pressure systems in the Tasman Sea. So if we've got a low pressure system, so a low that we have moving across the country, and then a high that's basically sitting down in the Tasman Sea region, which is basically between Tasmania and Victoria, then we've got a region there where we're starting to get some blockers. If there is warm surface water underneath this system, then this instability can certainly create some quite massive storms. There's been a number of events that we can identify in the past 150 or so years that we think either we know were directly related to East Coast lows, or we think because of the circumstances it must have been something like a storm associated with an East Coast low that has resulted in some of these disasters. So the wreck of the Dunbar, which occurred off South Head Rocks around 1857, the beaching of basically the wrecking of the Cygna in what became known as the Cygna Storm in 1974. That was grounded around Stockton Beach. In 2007, the Pasha Bulker was actually ground just off Nobby's Beach in Newcastle. And in 2016, we had the huge amount of erosion that was occurring along the northern beaches, particularly in the Collaroy area and Collaroy-Narrabeen kind of area, where a lot of damage was done to the beachfront, and it actually went in as far as a lot of the buildings that lined that section of the coast. So I was going to give you a diagram of a synoptic chart, which is what meteorologists use to look at weather and give you a nice classic East Coast low. But I actually thought I'd give you today's. So this is basically the synoptic chart. So it's a predictive chart, which means that the chart that I've got today is actually for tomorrow's date, which is the first day of autumn, the 1st of March. And here it is. And this is the problem that we've got at the moment. There's a couple of important things to remember, and obviously going to be interpreting these sorts of charts differently depending on whether you're in the Northern Hemisphere or the Southern Hemisphere. I can see that I'm in the southern hemisphere because I'm looking at a map of Australia. And because of that, I'm going to have low pressure systems with air moving around in a clockwise direction, so I can get a bit of an idea of which direction the winds are going around the low, and also in an anti-clockwise direction around a high. And these directions are actually reversed in the northern hemisphere, and that's partly a result of the Coriolis effect of the spinning Earth. But that's not what's causing these east coast lows. What we have are pressure systems. So a low pressure system is basically when we have air moving, rising. So this is why we need these warm waters in underneath that are lifting that air up, and obviously it's going to have a lot of moisture in it. And that's creating a low pressure system. A high pressure system is basically when the air is kind of pushing down on the surface, so that's why there's higher pressure. Think about the fact that there's always air above your head, so there's particles in that air, and particles exert a pressure. So if there's more particles in that same space, there's going to be more pressure. If there's less particles, there's going to be less space. And when we think about our what we've already looked at in terms of our convection cells, we know that it's going to rise where it's warm and it's going to drop where it's cool. And once they drop, they're going to push away. And as they rise, they're going to draw more in. So this is our classic low, and this is our classic high. Now, there's more to the story than this, but it's important that you start to get a bit of an idea when you look at some of these weather maps to try and get a sense of where things are. The other interesting things, I guess, when you have a look at this is we've got a tropical cyclone at the moment, and it's very possible, instead of the classic way that we find this sort of thing forming in the autumn or the winter months, where really you've got this Tasman Sea high, so this is the high in the Tasman Sea, we've got a low pressure system pushing across, we've got a trough, but in this case, what we've got is our low pressure system is actually moving down from the tropics. So this is often where you can have, say, tropical cyclones, high winds in these sorts of low pressure systems that are slowly moving south, and that they too can create the same sort of effects that we see from these east coast lows. But the problem that with this particular low at the moment that you'd be aware of is there's a huge amount of rain that's being released from this low pressure system, the cloud masses that are being brought onto land. And they're smashing the coast. They've created huge amounts of flood damage, lots of people losing homes, lots of people needing to be evacuated, and it looks like the rain's not quite over yet. The tropical cyclone that you can see up off the coast of Western Australia is also in the centre of a low pressure system, and often this is where the isobars, which are the lines that draw places of equal air pressure, get quite steep as they get sort of quite close together as that pressure drops very, very quickly. Or the same thing can happen when the pressure is rising very quickly around a high pressure system. So this is what we're trying to do. We're trying to find one of these east coasts. So here's our east part of Australia, and here's our coastline, and here's our low. And these sorts of formations can bring devastating effects as a result of the weather conditions associated with them. Now, while it's not critical for you to be able to read weather maps, what you do need to know is how these east coast lows can affect the environment. And of course, all you've got to do at the moment is turn the television on when the news is on, and you'll see exactly what sort of an impact these east coast lows are having on the human population and our buildings and infrastructure, as well as on the local ecosystems. One of the things that happens as a consequence of the formation of these east coast lows is we don't always get much warning. Often they hit very quickly, and there's stories of people who've had to go back to flooded houses just to try and rescue some of their most treasured possessions before they get destroyed by the water. And this is one of the problems with east coast lows, is sometimes the formation is so quick and the devastation is so great that there's not enough preparation time, not enough reaction time to be able to do anything to minimize the damages that occur. The high winds, potentially gale force winds, heavy rainfalls, and often surging surfs can have a big impact on the coast. It can lead to coastal erosion, can lead to inundation, and certainly the situation that occurred off the northern beaches of New South Wales in Sydney in 2016 was a good example of exactly how much coastal erosion associated with these sorts of events. But the same sort of thing you can see happening at Stockton Beach along that Stockton Strip. Currently, the East Coast lows and the rain that they've produced as a result has led to a lot of flooding. Inundation basically is another word for floods. And these and of course the problem with flooding is it doesn't necessarily happen straight away. Just don't get a lot of water building up. I mean, if your drains and things are blocked, then obviously you will get some sort of buildup of water. But the problem is that all of that water that's falling everywhere all will eventually flow down to the lowest point. And often that can be those coastal environments, those coastal suburbs, where the water levels just continue to rise even after the rain has fallen, as that water kind of keeps flowing down towards the sea. So this can obviously create massive damage to plants, to animals, to humans, and property. So we've got a big area of potential influence of these East Coast lows. And the fact that they can be a little bit unpredictable, the fact that we can't always tell exactly how fast they're going to form, exactly where they're going to, whether they're going to move, whether they're going to sit, what's going on with them, can contribute to the sorts of disaster that we can have as a result. So originally I thought it'd be interesting to have a bit of a look at the Cygnus storm and the damage that happened as a result of probably what was one of the biggest East Coast low events that we've got in recent history. It was suspected that the winds were up to around 165 kilometers an hour. So you're thinking cyclonic. You're thinking this is as close as often we're going to get to a tropical cyclone. These winds are very, very high, and they do an enormous amount of damage. And often if they are accompanied by rain as well, these two factors in together cause a huge amount of damage. And in this case, the Cygna was one of the recipients, I guess, at the mercy of this particular storm. But I also think at the moment it's quite useful to have a look at exactly what the sort of weather patterns are at the moment, to see how we can link them into our understanding of East Coast lows, and to keep an eye on the sort of damage that's happening right around us and potentially to us as these storms continue over the next day or two. So that's a little bit of real world earth and environmental science for you. Keep an eye on that, and thanks for watching.